we go. Okay. So we have Shanae, we have Ellen joining us right here. Elaine, another student of mine, sent in some questions to look at. As I mentioned in the initial breakdown, I kind of have like a priority that I give. So I give current students priority answering those questions, followed by anyone who is taking the self-paced online course, followed by everyone else. Because we have only a few people today, we should be able to get through everyone. But let's if you have questions, if you could email them to me, I'm going to put this in the chat right here. To this email address. Feel free to send out my way. That way I can.
I'm gonna send them. I have a couple of questions. If we don't get through all of them, that's completely fine. But the ones that I'm hoping we can touch on the some data analytical questions.
Yeah, you feel free to just send them, and I'll get to the ones that we get. I think we should be able to get to everyone's questions. Ellen says concepts, great. And so Ellen, I would say, if they are bring concepts tomorrow in the class, and I'll build those into the lesson, just so that everyone in the class can get them too. Focus today is on individual questions, but if we have time, I can certainly talk about concepts. I just don't want to like do it today and tomorrow, because we can cover anything that you need to tomorrow. So Elaine, who is a one-on-one student of mine, sent me a few specific questions here. Let me start with this one. So Elaine, if you're watching this after the fact, this one goes out to you. And it's a good one. So I'll blow this up. This is from one of the power prep tests. And her question that she wrote in the email was, how responsible are we for knowing the quadratic formula and knowing about quadratics? And the 100% safe guaranteed answer for the GRE is you do need technically to know the quadratic formula and to understand quadratics. However, it is very unlikely that you will actually have to use it, right? So I'll talk through this question, and I'll do it kind of the way that they explain here, and then I'll point something out about this after the fact. So welcome if you're just joining. We are going through questions. If you have individual questions that you would like addressed, feel free to send them to my email address, and I'll get those. So right now we're working on a question that Elaine sent in. So how many different numbers x satisfy the equation absolute value of x squared minus 5x equals 1? Well, first things first, let's talk about absolute value. And I talk about this in the course and in the self-paced course, but when we have an absolute value equation like this, we really want to start by breaking it into two pieces, or two potential outcomes. Either x squared minus 5x equals 1, or x squared minus 5x equals -1, right? And I don't want to go too far down a rabbit hole of absolute value, but this is what we do when we have an absolute value equation, is we split it into these two possibilities. Okay, so then we get x squared minus 5x minus 1 equals 0. And over here, x squared minus 5x equals plus 1 equals 0. I'm putting this kind of into quadratic form. Now, again, I will solve this the kind of right quadratic way, but I will just say this. Typically, and it's not always true, but typically, how many solutions do you get with a quadratic equation or quadratic function like this? Typically, you get 2, right? So this one is going to have 2 solutions. And this one is going to have 2 solutions for a total of 4 solutions. Now, obviously, this is not a completely thorough way to solve this, because you could have duplicates, right? maybe this gets like the solutions are 0 and 1 over here, and it's 1 and 3 over here. So that would be a total of 1, 2, 3 solutions. But if I'm just eyeballing this, I'm leaning towards 4. So you're completely pressed for time. Otherwise, the way to solve this, unfortunately, is with the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a, where a, b, and c correspond to the coefficients of each one of these. So in this case, the a would be 1, the b would be -5, and the c would be -1. We just plug it in and run it, and that gives us the two equations here. Now, here's what I'll say about this one. Normally, or rather, most questions are multiple choice. It's very rare that you have a student-produced response one or a numeric entry one. I mean, they happen, of course. This one's just particularly bad luck because it's numeric entry and it's the quadratic formula. So had this been multiple choice, we could have very easily leveraged what we had and plugged in the numbers here. But as sort of like a two-tiered explanation, that kind of like, guesstimate way, which is to say we have two quadratic equations, and the formulaic way, which is knowing the quadratic formula, is how we solve this. So I'll say you are technically responsible for knowing the quadratic formula, but it's very rare that you would actually have to use it. Yeah, so Jenny is going for even higher extra credit here. Jenny says, could you use the discriminant to find out how many solutions? And if you're taking the SAT, you really want to be familiar with that kind of thing, knowing what the discriminant is. And I'm hesitant to get too far in the weeds on it, but I'll just say this, Jenny. Or maybe Jenny, you want to hop in and let us know what the discriminant is.
Yeah, I can hop in. It's
Yeah.
basically a portion of the quadratic formula. So it's what's under that square root. So b squared minus 4ac. And if you get an even solution, it's an even answer. It's like 2. If you get 0, it means it's 1. If you get negative, it means there's no solutions, correct?
Exactly. Right. And just a little like tweak on that. If the discriminant is positive, I think you said
Oh,
even,
yeah,
but
sorry,
yeah, yeah,
positive. Yes, thank
I
you.
knew, I knew what you meant. Yeah. So if the discriminant is positive, if this piece under the radical is positive, you're going to get the square root of a positive number, which is plus or minus a positive number, and that yields two different solutions. If it's 0, it's going to be the square root of 0, which is just 0. So it's plus or minus nothing, which means that we get one solution. And if it's negative, then we have no real solutions. Okay. So again, quadratics, you kind of want to put on the back burner. There will almost always be a way to solve it, like quote unquote, creatively. This being a notable exception because it is numeric entry. All right. So again, I'm going to cycle through anyone who's a current student. I'll keep an eye on my inbox in case people are sending me questions here. Ellen sent one. So Ellen will go over to you on this next one here. And then Jenny will come to you. Okay, so here we go. Ooh, that's a good one. Sorry. That's what I'm looking for. Okay, great. So what is the least integer n such that 1 over 2 to the power of n is less than 0.001? Let me start with this. Does this number exist? Like, is there a cutoff point? And Ellen, you can feel free to actually answer this. Is there a cutoff point where at one point it's bigger than that and one point it's smaller than that? Ellen says yes, right? So, and just to get ourselves like warmed up, we could test a number. 1 over 2 to the power of 1. Is that less than that? No, because 1/2 is greater than 0.001. Okay, what about 1 over 2 to the 2. So 1 over 4, that's 0.25. Okay, that's a little better, but still not smaller. At some point, I cross over, right? I go from it not being true to it being true. And that means that there must be some number for which that's true. So we can get rid of this last answer option right off the bat. Now, realistically, and Ellen, I saw that, I don't know if you picked this one when you did it, or this was the highlighted correct answer, but realistically, 1 over 2 to the power of 500, that, like, this is a really, really big number, right? It's 1 over a really, really, really big number. So it's 0.000000000001. We're looking for something that kind of is in this range, right? The boundary. So probably not these two, because they're way too big. So it's probably going to be one of these two. And I know that raising something to the power of 10 feels like a fool's errand, like it's a lot of work, but we're talking about 2 here. So, and Ellen, this is a good little review of exponents. 2 to the power of 10, would you be okay with me rewriting as 2 to the power of 5 to the power of 2? Right? Exponent rules here. And I was, just in case anyone's wondering, I would have your powers of 2 memorized up to about 5. That's probably a good play, maybe 6. So 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 4 is 16, 2 to the 5 is 32, and 2 to the 6 is 64. I mean, you can always do this on your calculator. It's just going to be a little bit of computation. So this is 32, 2 to the 5, squared. Someone with a calculator, can you let us know what that is? What's 32 squared? Ends with a 4. Right, Ellen and Shirley? We were just talking about this in class. 1024. Yeah. Okay, so 1024. 1 over 1024 is what? As a decimal. What is 1 over 1024? What is it? 0.0009? Sorry, my eyes are a little blurry. 1, 2, 3 zeros. Great. 0.00097. I'm going to round, right? Well, is that number less than 0.001? It is, right? This only has 2 zeros and this has 3 zeros. And so it's asking what's the least number. So I want to start from the bottom. Like, this is the smallest number of this list, and it makes this true. So that's the correct answer. Just a strategic point here. When the question says, what's the least value, what's the greatest value, you want to start, if you're testing, you want to start at the highest or lowest value. And Ellen asks, is this like a medium or hard question? I would say, at first blush, it looks medium to hard, but when you really get down to it, and it just involves kind of plugging and chugging, I would put this squarely in kind of the medium category. Yeah. Excellent. Let's keep things rolling. Stop sharing this. We'll go to the question bank. So we did one from Elaine. We did one from Ellen. Let me just see if I've gotten any other emails here.
I just sent you an email.
Yes. Shanae. And I'm prioritizing current students
Okay.
yeah. But okay, and Jenny, I don't think we've like actually met in person. Is it Jenny or Genia, or how do you pronounce your name?
It's Jania, like Jen and Nia together.
Got it. Okay, so let's go with one from you, Genia, here. Great. The hundreds digit of the 5-digit number 73 blank 95 is missing. If the hundreds digit is to be randomly selected from the 10 different digits from 0 to 9, what is the probability that the resulting 5-digit number will be a multiple of 3? Well, I'll start with by saying this. We're not dealing with that many numbers here, right? If we were a worst case scenario, just plug in 0, 1, 2, 3, 4, we'd be writing out 10 numbers. Not the worst thing in the world. And in fact, I think that's the approach that I'm going to take. And I can shorthand it by just writing out 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. I'll give you a little bit of a shortcut on this, Jania, but for now, I given that this is so manageable, given that there are relatively few numbers, I might just write this out. Well, we want the probability that one of these numbers is divisible by 3. So I know that the denominator of the probability is going to be 10, right? There are 10 possible numbers we could have. Do I want to give you I'll give you the shortcut now, or maybe someone wants to hop in with a shortcut. Does anyone know the shortcut way to see if a number is divisible by 3? This is a fun little party trick, depending on what kind of party you're at. Anyone know the trick way to know if a number is divisible by 3? Someone wrote the chat here. Yep. So Ellen says add all digits. And if that sum is divisible by 3, then the number itself is divisible by 3. Right? So if we start with 73095, add those together, Jania, what does that equal?
Sorry, give me 1 second. I had dogs barking in the background. It's 24.
Which is divisible by 3, right?
Yes.
So that number is divisible by 3. Now, and again, I'm doing this the shortcut way. I want to emphasize that it's not the end of the world to go to each number here and divide by 3. It's a lot of computation, but here's the shortcut. If I know that this number is divisible by 3, Jania, what's the next number that's divisible by 3?
27.
What was that?
27.
Oh, yeah. If you add 3 to 24, right?
Oh, sorry. Yeah.
No, you're saying the right thing. I'm just saying which is the next number 73 blank 95 that is going to be divisible by 3.
Oh, 73395
Yep, right. 1, 2, 3 more, and then the one after that.
would be 73695.
Exactly, and then
73995.
and that's 4 numbers out of 10.
Ah, got it.
Yep. And I'll just say this. Sometimes I'm gonna get like a little philosophical here, but like sometimes like a journey of what do they say? Like a journey of 1,000 steps. It looks like it's gonna take forever. Taking like a very labor intensive step to start sometimes kind of like reveals the problem a little more. So even if it seems like a hopeless task to like write all these out, sometimes it's helpful. Great. That was a good question. All right. Keeping the rotation going here. That was Jania. Let me just see if there are any other current students. I saw people sent multiple questions, and I'll cycle back through. I just want to make sure that all current students have had at least one. So let's go back to Elaine, who sent in a question. This is another really good one. Whoops. Not that. Nope. All right, so this again is from Elaine. If n is an integer and n cubed is divisible by 24, what is the largest number that must be a factor of n? Okay, so n cubed is the same thing as n times n times n. Three integers that are multiplied together. Well, it tells me that this number, this n times n times n, is divisible by 24. That means I should be able to put 24 in the denominator. And when I cancel, terms out on top and on bottom, I should be able to cancel everything out on the bottom. Or I should be able to cancel out at least 24 on the bottom. Well, let's break 24 down a little bit. 24 is 3 times 3 times 3 times 2 if I do my prime factorization, right? N times n times n is 3 times 3 times 3 times 2, right? Well, clearly, let me ask it this way. What could n be, right? I need to have at least 3 of the same thing. N couldn't be 3 because I have this 2 left over. So assuming that 2 is part of the game, right, part of the party, I need to have at least 2 other 2's floating around in here so that I get 3 times 2 times 3 times 2 times 3 times 2. And so at a minimum, n times n times n needs to be divisible by this big number down here. And each n has to be at least 6, right? Each n has to be at least 6. Oh, I'm so, you know what? Ellen called me out on this. I factorized that incorrectly. 24, the prime factorization of 24 is not 3 times 3 times 3 times 2. I was like, what do you mean the other way? Yeah, the other way, which is 2 times 2 times 2 times 3. So let me backtrack there. It comes out to the same thing, I promise. But it is 2 times 2 times 2 times 3. Thanks for catching that, Ellen. All right. So the same sort of dynamic applies, and I'll run back through that. I need numbers where I have 3 of the same thing. So it's divisible by 24. That's all well and good, but that's not enough because I need this to be divisible by the same thing 3 times. So I need to add another 3 and another 3 in there. And so at a minimum, n cubed must be divisible by 6 times 6 times 6. And therefore, n at a minimum has to be 6. Okay, great. And Elaine isn't here at the moment, but she and I can talk about this offline. We need to. Let's move on to the next one. Ellen, let me just pull up your next question here. Oh, fun. Yeah. We'll do a little astronomy. Okay. So the sun is approximately 1,400 million kilometers from the planet Saturn. And light from the sun travels to Saturn at the rate of approximately 300,000 kilometers per second. How many minutes does it take for light to travel from the sun to Saturn? So, Ellen, I'll start with this. Generally speaking, what universe of question are we in here? No pun intended. Like what type of question is this? Ratios, yes. Even more specifically, given conversions, all true. Units, yes, true. But like given the type of units that we're dealing with, what am I kind of fishing for here? Right. Shanae has distance, speed, time, rate. Yep, exactly. So anytime I kind of see that's a foot, I'm gonna just write d equals RT, right? Distance equals rate times time. So I know that the distance that I'm dealing with is 1,400 million. Now, this is a little bit of a personal choice, but I personally like to write everything out. I don't like to sort of like benchmark and say like 1400, I'll keep track of the million on my own. I'm just going to write out 1400 million. So the distance is 1400, and then million is 123 kilometers. Units are very important here. And the rate is 300,000 kilometers per second. So rate is 300,000 kilometers per second. Okay. So we want to know how many minutes it takes for light to travel from sun to the earth. Well, let's calculate the time first in seconds, Ellen. How do I calculate the time if I have the distance and the rate? Yep, divide, right? Distance divided by rate. So that's 1400 million divided by the rate. And writing this out, again, maybe you kind of like scoff at me, but I'm not getting this question wrong, right? If I'm writing it out. 1400 million over 300,000. And I do my favorite little chopping zeros trick. The 2, 3, 4, 5. Did I get that right? Yeah, okay. So it's, and of course, this is not going to fit in your calculator, so we do have to chop those zeros down. And I get 14,000 divided by 3. Ellen, what does that number come out to? Four, 6, 6, 7. Sounds about right. So 466.6666. We'll just round that to 4667. Units are super important here, though. What unit does that? What is that unit of time? Seconds, right? Shanae, not kilometers per second. Kilometers per second is the rate, right? So the time is seconds. Where was I going with that? Yes. So 4667 seconds, but we want to know in minutes. And I know this is usually like this is probably like the whole thing, right? This conversion part is the hard part. If I want to go from seconds to minutes, Ellen, what do I need to do? Divide by 60 or multiply by 60? Divide by 60, right? And so what's 4667 divided by 60? 77.7, just about 80. Excellent.
Wait, Andrew, why wouldn't you multiply it by 60?
Great question, Shirley. And not like I think I'm guessing several other people probably had that question. They were maybe just a little bit afraid to ask. And the way to kind of prove it to yourself, Shirley, is to say, I'll give you an easier question. I want to convert 60 seconds to a minute. Or well, I want to convert 60 seconds to minutes. How many minutes is 60 seconds?
1.
1. And so to get from 60 to 1, did I divide or multiply?
Oh, yeah, you divided. Yeah. Yes.
Yeah. And Ellen brought up a great point. She said, I didn't realize this was a distance equals rate times time question. How can I easily recognize that? I'll give you one word right there, right? I have a distance per time. That's what kind of tipped me off, or that's what kind of says this is a distance rate time question. Yep. Excellent. Jania, I believe you're next. So let's go back to yours here.
I don't think my photo loaded, so I'm resending you a couple.
Oh, no worries. I think I got your first one. Oh, I got you the second one. Okay, great. We'll circle back around to you. So feel free to just send that in. Let me go to Elaine's last question here. Oh, and again, Ellen and Shirley, you're gonna. I'll ask you, Ellen and Shirley, to kindly hold your commentary because we just did this. We basically just did this one together. So if I can actually pull it up, let me see. Okay, there it is. Okay, so this one again is from Elaine. What is the remainder when 13 to the power of 17 plus 17 to the power of 13 is divided by 10? So I'll say this, units digit, any units digit follows a pattern. So for instance, let's take the number 3. I know this is 13, but let's take the number 3 just for starters here. 3 to the power of 1 is 3. 3 to the power of 2, if I multiply that by another 3, gives me 9. If I multiply this by another power of 3, 3 to the 3, I get 27. If I multiply that by another power of 3, I get 3 to the 4, 81. And at this point, I'm going to stop paying attention to everything except the units digit. When I multiply this by 3 to the 5, I'm multiplying this by another, or I'm raising this by another 3. It's going to end with a 3, 243. Multiply that by another 3 to get 3 to the 6. That's going to end with 9 because I'm multiplying the units digit by 3. Multiply that by another power of 3, 3 to the 7. That gives me, ends with a 7. So there's a pattern that emerges, right? It may not be super obvious right away, but once you know that every units digit has a pattern, you can fall back on this. 3971, 397, 3 to the 8, multiply that by 3, ends in a 1. So it's a cycle of 4 numbers, right? 3971, that's 4. So 3 to the 4 is going to end in a 1. 3 to the 8 is going to end with a 1. If I scale this up, I know that 3 to the 12 is going to end in a 1. And 3 to the 16 is going to end in a 1. Now, I know we were doing 3s, but this is true for 13 as well because we're only focused on the units digit, right? You can, on your own time, I would encourage you to, and Elaine, you and I can check in after the fact if you have questions about this. 13 times 13 ends in a 9. You raise that by a power of 13, it ends in a 7. You raise that by a power of 13, it ends in a 1. You're just focused on the units digit. So 3 to the power of 16 ends in a 1. If I go back to the cycle, what comes after 1? Well, 3. So I know that 3 to the power of 17 ends with a units digit of 3. I'll kind of bookmark that for now. Well, this one is kind of complicated for the sake of being complicated. I can tell this is from Manhattan. Manhattan likes to do that sometimes. 17 to the power of 13, we're going to do the exact same thing. So 17 to the power of 1 ends in a 7. 17 to the power of 2 ends in a 9. 17 to the power of 3 ends in a 3, 63. 63. 17 to the power of 4 ends in a 1. Let me make sure that I'm actually doing this right. 17 to the 1, the 7 is a 9, 3, 1. Great. 17 to the power of 4 ends in a 1. And 17 to the power of 5, we're back on that cycle again, ends in a 7. So the cycle is 7, 9, 3, 1. So every fourth one is a 1. And that means 7 to the 8 ends in a 1. And that means 7 to the 12 ends in a 1. And 7 to the 13 is 1 more beyond that. So it ends in a 7, right? 7 to the 13 ends in a 7. So I have 3 to the power of 17, which ends in a 3, a big number that ends in a 3. I have 7 to the power of 13, a big number that ends in a 7. If I add those together, the units digit is going to be 0. And if I divide that by 10, the remainder of a number that ends with 0 is going to be 0. Okay. And again, Elaine, if you have follow-up questions on that, we can talk separately. Okay. Let's see what's next. So, Jania, I think you resent this. Yeah.
Yeah, I
Great.
sent a bunch. You just want to choose one.
Okay, let's come back to this. So those were all of Elaine's questions. We'll go to Jania here. We'll go back to Ellen. Okay, T is a list of 100 different numbers that are greater than 0, less than 50. The number X is greater, I know this one, than 60% of the numbers in T, and the number Y is greater than 40% of the numbers in T. So we want to know what's greater, X minus Y or 20. Jania, let me ask you this question. How many numbers exist between 0 and 50?
51.
What about 31.2? That's a number, right?
Yeah. Oh, it's infinite.
It's an infinite number of numbers, right? It never, and this is I guess the moral of this story is pay attention to constraints, because there are no constraints on these numbers aside from they have to be between 0 and 50, but there are an infinite number of numbers. And I'm guessing, Ginny, it might have just clicked, right?
Yeah.
X could be anything, Y could be anything. And given that, I don't know if X minus Y is greater than 20, less than 20, or exactly 20. It could be any of those. So the answer has to be D, right?
Got it. Thank you.
Yeah. Great. Ellen, back to you. I think there was one. Oh yeah, your initial email. I think there was one more. A travel agent question. I'm gonna put that on the back burner. We'll get back to it. Let me just say it's not a super well written question. I know it is ETS official, and anyone who's taken that power prep probably knows the question that she's talking about, the travel agent question. Yeah, we'll just get it out of the way. I don't like this. I'm not like beating up on you. I'm mad at ETS for making this question and for keeping it on the power prep. It's not a great question. Okay. So this is giving people some like bad flashbacks here. If you've seen this already,
I sent the same one.
Yep. Oh, great. So, okay, 2 birds with 1 stone. Okay, so we have this table right here. We have a survey of 100 travel agents, each ranked A, B, and C in order of preference. Each of the 100 travel agents also rated the 3 airlines in 5 categories on a scale of 1 through 10, with 10 being the best rating. So we have that over here. We'll break that down in a minute. If each of the average ratings was the arithmetic mean of the ratings given by the 100 travel agents, approximately how much greater was the total of the ratings given to all 3 airlines for reliability than for promptness? It's just a badly written question. But Ellen, here's what I would just say about this. So let's take, for instance, just to pick a random value right here. Let's take 4.3, which is airline C's rating for convenience. What this tells us is that every number in this table is the average of 100 travel agents. So and going back to our average formula, the sum of the numbers divided by the number of numbers is equal to the average. Well, I know the average is 4.3. I know the number of numbers is 100, right? So the sum of all the travel agents has to be 430, right? I should say the number of points that airline C got was 430. So we can kind of do an Excel spreadsheet thing and basically for each one of these, multiply each one of these by 100 to get their overall total ratings. And this question, this terrible, terrible question, is a comparison. It's saying, how much greater was the total ratings given to all three airlines for reliability compared to promptness? So if I go to reliability here, I add these three together, 780, 750, and 490. What does that equal? $20.20, right? There it is. And then if I look at promptness, 650, 690, 410. What's that sum? 17 something? I'm going from memory here. 1750, yeah. And so here's the final insult, right? You do this subtraction and you get 270, right? 2020 is 270 more than 1750. And you're like, what gives? I don't see that answer in this table. Well, approximately. You can tell how much I like this question, given how given how my mood has shifted from all the previous questions. Every other one I was like, oh, this is a good one, this is a good one. And then I get this one, it's like, oh man, all right. And there is some, I don't know, like we can make lemonade out of this a little bit to say that when they say approximately, that's an indication that you aren't looking for an exact answer. I would argue this is a very approximate, but that is the correct answer here. And I know a few people were asking about this question. Is everyone all right with this? Any follow-up questions about this? Okay, great.
I have a question.
Oh yeah, Janine.
So in times like these, we would choose the closest answer because it's not actually the answer. I'm so confused.
Well, it's said that we're looking for a since it said approximate, we know that that's license for the answer to be a little bit off. So yes, the short answer to your question is yes, we're looking for the closest answer. This is another, like, to me, if the answer had been something like 253, like, okay, that's close enough. But when I get 270 and it's that far off, I start to wonder if maybe I did something wrong. And this is like, there's no like happy ending to this. This is kind of me just saying this isn't a super well written question, but it is 250 is the closest value to what we got, and that's the correct answer. Does that make sense to you?
Yeah, it does. And I feel like there's definitely been moments in taking practice tests where I've gotten a question and it says approximately and nothing aligns. So that's likely when I start to get flustered.
Right. Yeah, and I mean, I guess it's kind of just like a little hint that the question is giving you to know that the right answer is not going to be exact. Shanae?
Yes, question. I thought I was following, but what did you guys do to get the 1,750 and the
Oh, yeah.
2,020?
Yep. So, are you okay with the part where we're talking about the sum of this is 430, the sum of this is 800, the sum of this is 510? Is that part okay, Shanae?
Yes.
So, what was that?
Yeah, yes, I'm following.
Gotcha. So for promptness, what this is 6.5 is 650, 690, 410. And when I add 650 to 690 to 410, I get 1750.
Okay.
That's where I got this from. Because again, and this is, again, I keep beating up on this problem. It's a comparison. We're comparing the ratings for reliability compared to promptness. So I need to add all of these together and compare them to all of these. And the difference is 270.
Okay, that's all.
Excellent. Okay, so we got all the Lane's questions out of the way. So we'll bounce back and forth between Ellen and Jania here. This one came from Ellen, so let's go over to Jania. I know Jania, this was one of the ones that you had. Ooh, yeah.
Which one are you gonna do?
I was gonna do the next one that you sent, which is the probability one.
Oh, yeah, okay, perfect.
Yeah. And let me just say a word generally about probability. And I said this to Ellen and Shirley today in class. Probability questions are, first of all, very rare, right? And they're very hard. Like there's no sugarcoating it. Probability questions, including this one, are very hard both conceptually and computationally. Like it's going to take a lot of thinking, and oftentimes it's going to take a lot of like number crunching to do these. So I like to say to people, don't even touch these until you're already at about high 150s or 160, right? When you're trying to make the move from like 160 to 165, that's where you want to invest some time in doing these. So we'll do this because I think it's a good question to look at. But just want to kind of preface that about probability. Okay, so this problem comes down to this idea of mutual exclusivity. Jania, do you have a definition of that? How would you define mutually exclusive?
When two events are mutually exclusive, that means that they cannot happen at the same time.
Exactly. Right. And so let's do a concrete example of this. And it might sound a little absurd, but I think it makes it very clear. It's impossible for it to be Tuesday and Friday on the same day. Someone right now is like, well, what about time zones? No, it's impossible for it to be Tuesday and Friday on the same day. Those are mutually exclusive events. Here's an even more stark one. It's impossible for it to be raining and not raining at the same time. So now let's apply this a little bit to the world of probability. And I'll kind of run through like a series of questions here. So Jania, what's the probability of rolling a 1 on a fair 6-sided die?
1 in 6.
What's the probability of rolling a 2 on a fair 6-sided die?
1 in 6.
6 and a 3, 1 in 6, and a 4, 1 in 6, and a 5, 1 in 6, and a 6, 1 in 6. These are the only possible outcomes for rolling a die, right? There are 6 possible outcomes for rolling a die, and they are mutually exclusive, meaning that they can't overlap at all. You can't roll a 2 and a 1 at the same time. Jania, what do these all add up to?
6 out of 6. 1.
1, right? Because they are the only possibilities and they are mutually exclusive, they have to add up to 1. Is that piece okay, what I just said?
Yeah, that makes total sense.
And so we can just apply that to this, right? We're not dealing with a nice even die here. This is a loaded die. It's a 3-sided die with different probabilities. But P plus P over 2 plus P over 4 has to equal 1. You buy that part? You buy that jump?
Yeah. Yeah.
Right? And so then it's just an algebra problem.
Got it.
So that's 4P over 4. Call this 2P over 4. If I put this all in the common denominator, add these together, I get 7P over 4 equals 1. So P equals 4 over 7.
Oh, okay.
That's a good one. All right. Ellen, back over to yours. This is line A has a slope of Negative 5 over 3. Okay. Line A has a slope of negative 5/3 and passes through the point negative 2, 7. What is the x-intercept of line A? Great. So, well, I'll put it in the form of a question, Ellen. What type of question or what sort of like topic are we in right now? What topic is this? Yep. Sorry, I couldn't see. Coordinate geometry, right? And specifically slope. And so I have this kind of like, connection to coordinate geometry, slope. I'm probably going to have to deal with my favorite equation, y equals mx plus b. So I'll just check, Ellen, did that equation pop into your head when you saw this to start?
Yes.
Great. That's a great first step. What does the m represent?
Negative 5 over 3.
Negative 5 over 3, which is what we have in this case, negative 5/3 x plus b. And now we have call it an incomplete equation. Fortunately for us, though, we have a point that satisfies this equation. And for those of you been in class with me, you know that I like to kind of like explore a lot of the whys and why we do this. But this is a case where I'm comfortable in saying if you have a partial equation, which we do here, and you have an xy point that satisfies that equation, that passes through the line, or that the line passes through, just plug in the x and y values. And maybe in class, if you want to like talk about that a little more, we can, but this is just like an automatic thing. If you have an incomplete equation and you have an x and y point that satisfy that equation, plug them right in. So what do I get when I do that? I get 7 for the y equals negative 5 over 3 times negative 2 plus b. And so let's solve for b here. What do I get? I get 7 equals positive 10 over 3 plus b. So 7 equals 10 over 3 plus b. Subtract 10/3 from both sides. So that's, I want to call that 21 over 21. 21 over 3, I'm sorry. 20 over 3, subtract 10. B is equal to 11 over 3. So B is the y-intercept of this line. Ellen, so far so good?
Yep.
Right. So then, and this is how you know this one's not an official question because I feel like the ETS probably would have been satisfied at that point. But where is this from, out of curiosity? I don't recognize the font.
Magoosh.
Okay, great. Did I do this one on Magoosh? Was that me?
I don't think so, no.
Yeah. So the y-intercept, what did I say? It was 11 over 3. So y equals negative 5/3 x plus 11 over 3. We know what the y-intercept is, at least in this formula. What is the x-intercept, Ellen?
When y equals 0.
When y equals 0, so let's just set y equal to 0, right? 0 equals negative 5/3 x plus 11/3. So I can subtract 5/3 from both sides, or well, 5/3 x, or sorry, add 5/3 x to both sides so that that cancels out. And I get 5/3 x equals 11/3. Multiply both sides by 3. So 5x equals 11. X equals 11 over 5. That's what I get. Questions on this, huh?
Nope, that was great. Thank you.
Yeah, Magoosh likes complication for the sake of complication. They like fractions. All right. So Jania, you had a few more here, and then Shanae, we can go a little longer. I'll get to a few of your questions here, Shanae, but let's go to Jania's. Um, let's do, yeah, let's do the train one. Okay, so this question, well, first off, what type of question or what kind of patterns might come in handy on this one, Jania?
Distance.
Distance, rate, time. So I kind of have that kicking around in my head. DRT, I'll put that up in the corner here. But even more generally, this is a variables in the question, variables in the answer type problem. And when that's the case, what can I do?
I don't know. What can you do?
Ellen or Shirley, what can I do?
You can just use your own numbers.
Exactly. Right? Because, and here's like the logic of why we can just pick a number out of thin air. The question is vague, but so are the answer options. So as long as I respect the constraints of the problem, and there aren't really any constraints. I mean, I guess technically you have to have, it has to be positive, right? Can't go like a negative distance. But as long as it's positive, or as long as it's positive, any number should work and carry through into the correct answer. So Jania, how many miles is S?
5,
And how many hours is T?
2.
2. So right there, we may want to just do like a little check for ourselves and say, okay, 5 miles in 2 hours, how fast am I going? How many miles per hour?
5 miles, 2 miles per hour. Like, oh, right. So you're doing 2.5 miles an hour.
Yeah, right. And again, that's not necessary for the problem, but I like to just kind of check in with myself on the way
Yeah.
and make it more concrete. So I'm going 5 miles in 2 hours. How many hours will it take to travel? What do you want to call Y?
7 miles.
Why not? Right. And I know I can kind of hear the skepticism in your voice, but it works. And we can try it again with different numbers. So if I'm going 5 miles in 2 hours, how many hours is it going to take me to go 7 miles? We just have this proportion here.
$2.8 hours.
2.8, right? 14 divided by 5, 2.8-ish. Or that is probably exact, right?
Yeah.
2. And so all we have to do now, and I'll kind of like write this over here. S was 5, T is 2, and Y is 7. Which one of these, when we plug them in, gives us 2.8? Some of them we can eliminate right off the bat, right? Like 12 divided by 2 is not 2.8. 2 divided by 14 is less than 1. T times Y, 14 over 5, that's exactly what we got, right? Neither of these ones work. And I know, Jania, it's like, is that always going to work? Anytime you have variables in the question and variables in the answer, you can pick your own numbers, as long as you respect the constraints of the problem, right? So like if it had said something like, T has to be less than 5, we would have to respect that. But as long as we're doing that, whatever we pick in there should work.
Got it. Yeah, I think I get overwhelmed when there's variables and I'm kind of trying to figure it out.
Totally. Yeah. Because it's not natural to think of the world in abstract terms like this, right? We want to think specifically. So like let's let our minds be specific. Great. Okay, so we did the airline one. Let's do I'm gonna do the proportion one. The developer one is a little bit labor intensive. I think, Jania, we're meeting in a couple weeks, right?
Yeah, I'm gonna email you to see if I can also put another session on the calendar.
Yeah. Let's if you don't mind, let's save the developer one for then, just because
Okay,
it's a little bit annoying.
got
I,
it.
I have my favorite ETS questions, my least favorite ones, but this proportion one, let's definitely take a look at. Okay. And what we just talked about applies to this as well, right? Quantities S and T are positive and related by this equation. S is equal to K over T, where K is a constant. Very often we kind of just gloss by that. We're like, okay, K is a constant, but it really matters here. The value of S increases by 50%, and the value of T increases by what percent? One thing to note about this problem is that there are no concrete values, right? And so effectively what the problem is saying to us is like, this is true no matter how big or small the numbers are. We're respecting the constraints of the problem. So, Jania, could you give me 3 numbers, S, K, and T, that would fit into this equation?
Mm, K could be 10.
Right.
T could be 2. So then S would be 5.
Excellent. So let's run with that. Like that is a possibility. Like that, those 3 numbers could be S, K, and T. There's nothing stopping them from being S, K, and T. So 5 equals 10 divided by 2. Okay, but then we have to remember that K is a constant. So K is locked in. K is not changing. K is forever 10. We're going to increase the value of S, that's 5, by 50%. What is, and let me actually color code this. I'm going to make this blue because it's special, right? It's locked in. If I increase 5 by 50%, Jania, what do I get?
7.5.
7.5 equals, well, again, 10's not allowed to change. So the denominator there needs to adjust. What value will make this true now?
Wait, I'm getting 1 second.
No rush.
3.
Would it be 0.75?
Not quite, because we're solving for X, right? So if we want to isolate X, got to multiply. Osuji mentioned this in the comments. If we pick the same numbers, well, no, and I'll get to that question in a second. But the second part of what you said, Osuji, is correct. It's 1.333, and here's the algebra behind that, which is if I'm looking for X by itself, so let's multiply both sides by X,
Yeah.
right? So that cancels out, and I have 7.5X equals 10, or I should say T, right? Because that's the T right there. So
Oh, I did my math backwards. Okay.
you did 7.5 divided.
Yeah, that's why I did it. Yeah.
Yep. And so when we do that, we get 1.333. So in setup 1, K was equal to 10, T was equal to 2, and S was equal to 5. In setup 2, K is still equal to 10. T is now equal to 1.333, and S is equal to what did we say? 7.5, right? The question is, by what percent did our T decrease? We went from 2 to 1.333. So what percent decrease is that?
Is that a 66%?
It is a 33% decrease.
33%. Okay.
Right. I mean, it's a little confusing because 2 minus 1.33 is 0.6, but
Yes,
that
the other way. Got it.
is 1/3 of that. Yep. So once again, picking our own numbers saves the day. Great. Okay, so I think
where you guys got the fraction. So I'm up to 1.333, but then after that, I don't know what happened.
so. Okay, so Shanae, you said you got this far. You got as far as 1.333.
Yeah.
Got it. And so then the last step is talking about the percent decrease. So we went from 2 down to 1.333. And so Shanae, I'll ask you, do you know the formula for percent change? That's the key here.
Oh, yeah, I just realized. So it's the difference between the two over the original multiplied by 1.
Exactly. Right. So the difference between the two, which is 0.6667, divided by the original, which was 2 times 100, if I want it as a percent, and that gives me 33.333%. Excellent. Okay, so I believe, let me just check my email. I believe that is all of the enrolled students, the people who've sent in their questions for review. Again, Jania, if you don't mind, we'll just do that late frontage one later because it's a little annoying. Yeah. And then Ellen, I think we got all of yours as well, right? Sorry, there was one more. The triangle one, let's talk about the triangle one in class tomorrow, since that was a class question. But let's look at this even.
No. Yes, that's one.
Yep. And I will just ask here, Ellen, what interesting word is in that
Must.
question, right? Which immediately translates, if something must be true or must be even, we immediately go to cannot be false, right? And so I'm guessing, Ellen, you can tell me, did you tried this with like testing numbers, you're looking for a quicker way?
Exactly. And then I was down to 2 options,
Okay, which two?
the last 2.
Got it. So you maybe like started with 1, right? And that got rid of these nice and easy. And so when we plug in 1 here, we get 1 plus 3, which is 4, plus 8 is 12. That's even. And 1 plus 2 is 3. Well, that's odd right there. So 1 disproves this one.
Yeah, I think I started with 2, but yeah.
Got it. Yeah. I'll give you kind of a, I don't
Or
know,
maybe 0, I think actually. But yeah, go ahead.
zero would be a great one to start with, right? Because that gets rid of A and C right off the bat. With this one, I mean, you're kind of really the only efficient way to do it is to test. What you could do is say, all right, this is odd. If I make X odd, then this is odd, and odd times odd is odd. So odd plus odd plus odd is odd. So no. But then you're doing the same thing. You really just kind of have to test here. Okay. So, Shanae, we'll do 1 or 2 of yours. Do you have a preference, Shanae, which one you want to start with? And I think we got a few of the ones that you sent.
Yeah, you guys some of them. We could do the other 2 of the graph questions.
The other 2 in the graph. Yeah, okay.
Yeah.
Yeah, my least favorite questions. Okay. So let me just get this here. Yep, that's the one, right? Load this up a hair. Okay, so we did this one together. Let's do this one. And sorry for the small font. If everyone can read that. Yeah, okay. There we go. Okay, so airline B's average rating for convenience was approximately what percent greater than airline A's average rating for convenience? So, Shanae, if we look at airline B for convenience, we get 8. And if we look at airline A for convenience, we get 5.1. So this is like the percent, it's a percent change question. So we basically do the increase from this to this divided by the original. And so what is the increase from 5.1 to 8? $2.9, right? So that's a 2.9 increase divided by the original, which was 5.1. And when we do that division, I think we get 0.5666 maybe. And so what this one is just a percent change. Is that all right, Sinead?
Yeah, it's fine. I guess reading through the question, it kind of seems jumbled and confusing. So when I was reading it, I couldn't put the pieces together.
Yeah. And I brought this up in class today with Ellen and Shirley, which is that these questions, right, they are going to take time. Even if the concept ends up being easy, they are a big time suck. So my recommendation is save them for the end, right? Don't waste your time trying to read the graph and trying to understand the question. Save that for the very end. Okay, let's do the last airline question. Each of the average ratings was the arithmetic. Oh, no, we did this one. Was it the other one that we didn't do? Oh, here we go. Yeah. The sum of the 5 average ratings was calculated for each of the 3 airlines. The airline with the least sum was ranked first by what fraction of the travel agents? So we could add all of these ratings together for each airline. But I mean, let's look at these airlines. Which airline do you not want to fly on? Just by eyeballing those numbers, Shanae. Probably C, right? That's the Spirit Airlines of airlines. Right? Airline C is clearly the least ranked. So that saves us a little bit of computation of having to like add all these together, right? So we're talking about airline C. Now, if we look at the table, right, which slices of pie ranked C first? This one and this one. And Shanae, what fraction do those account for overall? Out of 100, how many are we talking about?
Less than a quarter. Looks like less.
What was that?
It looks like less than a quarter.
Less than a quarter, but specifically, out of 100, how many?
Oh, I don't understand how to read the graph overall, so I think that's the thing. It's
Gotcha.
20 plus the 2.
It's 22, yeah. And so just to kind of explain what this graph is all about, BAC, so 34 ranked B first, then A, then C. 20 ranked B first, then C, then A. 20 ranked C first, then A, then B, and so on and so forth. So what the question is asking is, what fraction of people ranked C first? And the answer is 22, right? Because that's CBA and CAB. So that's 22 out of 100 or 11 out of 50. And that's where that comes from.
Okay, well, the question seems easy now that you did it.
Yeah, it's again this problem. Everyone asks about this problem set. I'm very used to this problem set. I mean, like, it's interesting that, some people rank C first. Maybe they like serve some, like, nuts or something on the airline that everyone loves so much. Like, it's a terrible experience, but man, those peanuts are great. I don't know. Okay, so that's all I have time for today. As always, please feel free to email me. These office hours are relatively new. I'm gonna try to do more of them. Again, I feel a little like weird about, giving priority to certain people, but I do want to give priority to the people who are studying with me at the moment. Um, if you want to chat for 10, 15 minutes on my website, there's a scheduling link. Um, I am going to be out of town for the next couple weeks, with very, very limited availability. I have, if you're like urgently in need of like a tutoring session and it's like life and death, I have a colleague who's very, he and I like trained at the same company, so he knows all the cool tricks. He's covering for me in that time. You can feel free to reach out to me and I'll connect you with him. Otherwise, Ellen and Shirley, I'll see you both tomorrow, and talk to everyone soon.
Okay, thank you very much.
Take care. See you.